Hello everyone. Today's topic is Laplace transform on unit step function. In my last lecture, we have learned how to use Laplace transform on periodic function. One thing I have forgotten in my last lecture that Laplace on periodic function, you can apply only Laplace transform. Periodic function is not applicable for inverse Laplace transform. Okay, actually this is not in your syllabus. So for periodic function, only you have to learn the Laplace transform, not inverse Laplace transform. Okay. Similarly, in unit step function, only you have to learn Laplace transform, not inverse Laplace transform. Clear? So that's why today's topic name is Laplace transform using unit step function. Okay. So let's start. First, we have to understand what is unit step function. Actually, we can denote unit step function by the symbol ut minus a. Okay, we can use unit step function by this symbol ut minus a. Now, what is ut minus a? Ut minus a, this is equals to 0 when the value of t, this is less than a. Okay, and this is equals to 1 when the value of t, this is greater than or equals to a. Clear? This is the definition of unit step function. So a function whose value is 0 when t is less than a, and this is 1 when t is greater than or equals to a. In particular, suppose this point a, this is the origin point. Okay, so in that case, unit step function will be ut, this is equals to 0 when t is less than 0 and 1 when t is greater than or equals to 0. So what will be the graph of unit step function? Let's try to understand. Suppose this is our x, not actually x-axis, this is our t-axis, because here the variable is t and u. So this is t-axis and this is u-axis. Now it is saying that when t is less than a, let's say this point, this is the a point. Okay, when t is less than a, the value is 0. When t is greater than equals to a, the value is 1. So for greater than equals to a, this point is a now. So and let's say this is the point 1. So for greater than or equals to 1, this is the when t is equals to 1, this is the value 1. Okay, now t greater than equals to a, the result is 1. That means you are getting a straight line parallel to t-axis. Okay, and when t is less than a, the result is 0. That means a straight line on t-axis. This straight line on t-axis. Okay, this is the graph of unit step function. Okay, when a is less than 0, you are getting a straight line on t-axis, and when t is greater than equals to a, okay, greater than equals to a, not 0, greater than equals to a, in that case you are getting a straight line parallel to t-axis at a distance 1. Similarly, suppose this is t-axis and this is u-axis. This is the point axis t, u. Here the point is 0. That means this point. Okay, and when t is less than 0, you are getting a straight line on t-axis, this one. Okay, and for greater than equals to 0, this one. Let's say this point is 1. Okay, so this is the graph of unit step function. Okay, now let's understand how we can apply Laplace transform on unit step function. Here you have to remember a basic formula only for this standard unit step function. Okay, only for this standard unit step function, the formula is Laplace of ut minus a, this is equals to e to the power minus as divided by s. Okay, this is for only this unit step function, but remember this is not the original formula. Okay, you can conclude this result from the original formula. Okay, so let's come to the next topic. Actually, unit step function that will not be given. Okay, you will be given a function, a simple function. Okay, and you have to convert the function using this unit step function. Okay, for example, suppose I am writing, you have a function capital F of t. Capital F of t, this is equals to f1t when this is when t is less than a. When t is less than a, and f2t when t is greater than equals to a. This function is given. Okay, obviously this function, this is not unit step function. Why? Because in unit step function, the functional value is only 0 or 1. Yes, clear? So first you have to convert this function using unit step function. Okay, you have to convert this function f of t in linear form using unit step function. How? Actually, you can convert this function in this form. F of t, this is equals to, what is the first function? This f1t. This is your first function. So f1t, okay, plus second function minus first function. So f2t minus f1t, okay, into unit step function ut minus a. This is the in this way you can convert any function using unit step function. Okay, now in this result or in this formula, what is unit step function? This ut minus a. This is your unit step function, and you have converted this function f of t in this linear form. Now I am saying that this function f of t and this linear function f of t, these two functions are same. How? Because you know that ut minus a, this is equals to 0 when t is less than a and 1 when t is greater than equals to a. Now, when t is less than a, the value is 0. Let's say I am taking t is less than a. So obviously this will be ut minus a, that will be 0. That means f2t minus f1t, this portion is cancelled. This is 0. So you are getting ft equals to f1t. Here you are getting when t is less than a, ft equals to f1t. Clear? Similarly, when t is greater than equals to a, ut minus a, this is 1. If you put here 1, so you are getting f1t plus f2t minus f1t. So f1t, f1t cancel. So you are getting f2t. You can see for t greater than equals to a, the result is f2t. Clear na? That means these two results, this function f of t and this function f of t, both are same. Just I have expressed the function using unit step function. Okay, now suppose here we have two functions now, f1t and f2t. Remember, when you are converting the function into linear form, which function you have to take as first function? Here I have written f1t, this is our first function. Okay, but how you can understand that this is your first function? When the variable t is less than a, that will be your first function, and when the variable t is greater than a, that will be your second function. Clear? That's why f1t is our first function and f2t, this is our second function. Now suppose we have a function where the function f of t, this is divided into three different regions. Okay, here the function f of t is divided into two regions. Okay, now we have a function where the function is divided into three regions. In that case, how you can convert into this linear form? So let's Next theorem, f of t, this is equals to, let's say, f1t when t is less than a1, f2t when t is when t is a1 less than t less than a2, less than equals to a1 less than equals to t less than a2, and f3t this is a2 less than equals to t less than a3. This is the function. Okay, not actually a3 because upper limit is infinity, so only t greater than equals to a2. Okay, or you can say a2 is less than equals to t. Can we say which one is first function, which one is second function? If you take a look on these two results, here a1 is common, yes or no? In first case t is less than a1, in second case t is greater than equals to a1. So for these two functions f1t and f2t, f1 is your first function, so you can convert in this way. Ft, this is equals to, first you have to add f1t plus second function minus first function, that means f2t minus f1t minus f1t, okay, into unit step function, and here the point is a1, so you have to write ut minus a1. Clear? Similarly, in second case here the point is a2, yes or no? In this case t is less than a2, in this case t is greater than equals to a2, so similarly plus you can write f3t minus f2t into ut minus a2. Okay, this is the linear form of the function f of t. Okay, now you have to apply Laplace transform on this function or on this expression. Okay, and you have a result, or you have a property of Laplace transform for unit step function, and the result is Laplace of f of t minus a ut minus a, this is equals to e to the power minus as Laplace of f of t. Very useful result, and actually this is the original formula of Laplace transform on unit step function. Okay, this is the original formula. So Laplace of f of t minus a ut minus a, this is equals to e to the power minus as into Laplace of f of t. In my previous slide, I have written that Laplace of ut minus a, this is equals to e to the power minus as by s. Yes or no? I am getting this result actually from this original formula. How? Laplace of ut minus a, this is equals to e to the power minus as divided by s. Okay. Here Laplace of ut minus a, that means f of t minus a, this is equals to 1. Yes or no? F of t minus a, this is equals to 1. So you can see f of t equals to 1. So the result is e to the power minus as Laplace of 1. Yes or no? And you know Laplace of 1 equals to 1 by s. So you are getting e to the power minus as divided by s. This result. Clear now? So actually this is the original formula in unit step function. Now in maximum cases, you will have to use the formula, this one, Laplace of f of t into ut minus a, this is equals to e to the power minus as Laplace of f of t plus a. In maximum cases, you have to use this formula. Okay, actually here the function is f of t minus a, and here I have written f of t. That means this variable t is replaced by t plus a, and a cancelled, you are getting f of t. Yes or no? Only for f of t minus this function. So the variable t is replaced by t plus a, and you are getting f of t. Similarly here, the variable f of t, the t is replaced by t plus a, so you are getting f of t plus a. And this result is very, very important. Okay, maximum, you have to use, in maximum cases, you have to use this result. Okay, Laplace of f of t u t minus a, this is equals to e to the power minus as Laplace of f of t plus a. Okay, now let's understand this topic by solving some problem. Question: express the following function. Express the following function in terms of unit step function. Okay, and the function is f of t. This is equals to t minus 1 when 1 less than t less than 2, and c minus t when 2 less than t less than c. Okay, and find Laplace transform. Solution: first you have to express the function in terms of unit step function. Okay, so you can write this here, the function is f of t. This is equals to t minus 1 when 1 less than t less than 2, and 3 minus t when 2 less than t less than 3. Here you can see the common point is this point 2. Okay, and here you have the less than sign, and here you have the greater than sign, t less than 2 and t greater than 2. So obviously I have told you that less than sign, that will indicate the first function. So t minus 1, this is your first function. So you can write f of t, this is equals to t minus 1, okay, plus second function minus first function. So 3 minus t minus t minus 1. Okay, second function minus first function into unit step function, and the point is a is equals to 2 now. This is your point, so u t minus 2. Okay, this is the expression in unit step function. Okay, if you want to simplify it, so t minus 1 plus, this is 3 minus minus plus 1, that means 4. Okay, 4 minus 2t, 4 minus 2t u t minus 2. That means you are getting t minus 1 plus 2 into 2 minus t u t minus 2. Okay, this is the expression of the function f of t in terms of unit step function. Okay, now you can write or you can explain what is ut minus 2. So where ut minus 2, this is equals to 0 when t is less than 2, and 1 when t is greater than equals to 2. Okay, now you have to apply Laplace transform on the function f of t. Clear? So next page. Laplace of f of t. This is equals to Laplace of t minus 1. Yes. Plus 2 into Laplace of 2 minus t into u t minus 2. Okay. Laplace of t minus 1, you know. Laplace, what is Laplace of t minus 1? This is equals to, achha, you can calculate it separately. Let's say this is equation number 1. So Laplace of t minus 1, this is equals to Laplace of t, this is 1 by s square, and Laplace of 1, this is 1 by s. And now Laplace of 2 minus t into u t minus 2. Okay. So you know the formula that Laplace of f of t u t minus a, this is equals to e to the power minus as Laplace of f of t plus a. Yes or no? This is the formula. Now if you compare these two results, f of t equals to 2 minus t. Yes, f of t equals to 2 minus t. That means you are getting e to the power minus, what is the value of a? A is equals to 2. So e to the power minus 2s into Laplace of f of t plus a. So you are getting, what is the value of f of t? 2 minus t. So 2 minus t will be replaced by t plus 2. So 2 minus t plus 2. Yes or no? If f of t equals to 2 minus t, so what will be f of t plus 2? That means 2 minus t plus 2, na? Yes, I have written this. Okay, so you are getting e to the power minus 2s into Laplace of this 2 cancelled, so you are getting Laplace of minus t. Okay, so minus is out, so minus e to the power minus 2s, and Laplace of t is equals to 1 by s square. Okay, so from 1 you are getting Laplace of f of t, this is equals to 1 by s square minus 1 by s minus, actually here you have 2, so minus 2 e to the power minus 2s divided by s square. This is the final answer. Okay, okay, sorry, this will be s, 1 by s. So 1 by s square minus 1 by s minus 2 e to the power minus 2s divided by s square. Clear? Let's solve another problem of unit step function. If f of t, this is equals to sine t when t is greater than pi, okay, and cos t when 0 less than t less than pi. This is our given function. You have to find Laplace of f of t. Solution. So in this function f of t, which one is first function? Sin t when t is greater than pi, and cos t when t is less than pi. So obviously cos t, this is your first function because you have less than sign and the common point is pi. So this cos t is your first function. So you can express it, f of t is equals to first function cos t plus second function minus first function. That means sine t minus cos of t, okay, into unit step function, that means u t minus pi. Okay, now you have to apply Laplace transform, or you can write here that where u t minus pi, this is equals to 0 when t is less than pi and 1 when t is greater than equals to pi. Okay, now Laplace of f of t, this is equals to Laplace of cos t, yes, plus Laplace of sine t into ut minus pi, okay, minus Laplace of cos t into ut minus pi. Okay, you know Laplace of cos t equals to s by s square plus 1 plus Laplace of sine t into ut minus pi. You know the formula, e to the power minus as into Laplace of f of t plus a. That means here you can write e to the power minus pi s, e to the power minus pi s into Laplace of sine t plus pi. Yes, formula is f of t plus a, e to the power minus pi s Laplace of f of t plus a, and here a is equals to pi, so sine t plus pi. Similarly, minus e to the power minus pi s Laplace of cos t plus pi. Okay, now what is the value of sine t plus pi? Sine t plus pi equals to minus sine t. Okay, similarly cos t plus pi equals to minus cos t. So you are getting s by s square plus 1 plus e to the power minus pi s Laplace of minus sine t. Okay, minus e to the power minus pi s Laplace of minus cos t. So finally you are getting s by s square plus 1, this minus is out, so minus e to the power minus pi s divided by s square plus 1, because Laplace of sine t is 1 by s square plus 1, and this minus is out, so minus minus plus Laplace of cos t is s by s square plus 1, so this will be s into e to the power minus pi s divided by s square plus 1. Okay, if you want to simplify this, so this is equals to s plus s minus 1 and e to the power minus pi s is common, divided by s square plus 1. Okay, this is the final answer. Okay, now try your question bank problems. Okay, there are many problems using unit step function. Thank you so much.